Let's look at the 5.4 homework assignment. So for this section, the first problem is very simple, and I'm not quite sure why they put this one in there, but it's just asking us to evaluate a polynomial at a specific value. So p of x is equal to 3x to the fourth minus 2x squared plus 6, and we're supposed to find p of 4. So obviously, that's just going to be p times 4 to the fourth minus 2 times 4 squared plus 6. I did 4 to the fourth is 256. 3 times 256 would be 268. Then we're subtracting 2 times 16 minus 32 plus 6. Got a final answer of 742. And so when I go in here to achieve, I go 742, check answer, and of course correct. Now for the second one here, this is the second time it's done a problem like this. We had one in a previous section like this, but the reason it's asking us to multiply out polynomials like it is in this problem is it's trying to drive home the point. Anytime you have a multiplication within an integration problem, you have to do the algebra before you do the calculus. So in this problem, what I did to show my work here, in order to multiply this out, I distributed the 6x to the fourth times both of the terms in the second group. I got my 48x to the sixth plus the 30x to the fourth. Then I distributed the 6x squared through both of those terms, getting the 48x to the fourth plus 30x squared. And then the 9 distributed to both of those terms, the 72x squared plus 45. After that, we pretty easily collect like terms. There is no like term with the x to the sixth, so just 48x to the sixth. We have 2x to the fourths. Add those coefficients to get 78x to the fourth. Again, we have 2x squared terms. The 30 and the 72 combine for a coefficient of 102. Of course, plus our constant of 45. Now, when I compare that to what they have here, there's only the one answer that matches, of course. And we'll check that, and it's saying we are correct. For the next problem, this is just trying to explain the fundamental theorem of calculus part 1, the evaluation theorem, where it's just saying that a function of f of x with respect to x from a to b, it's just the antiderivative evaluated at a minus the antiderivative evaluated at b. I'll go ahead and hit the play button just so I can get credit for it. But that's what they're discussing in this video. Please do take a chance to go ahead and look through it and make sure you understand what's going on. Now, for the next problem here, we're doing a problem in which we have to carry out that multiplication before we do the calculus, the integration. So in this one, whenever I'm trying to work it, I can go in and say, well, I have to multiply out the two binomials, 8x squared minus 2 times 2x plus 3. When I'm multiplying these out, I can go ahead and say, so now once you do the algebra and you FOIL out those polynomials, it becomes a very easy function to go ahead and integrate. It's just the power rule for each of the terms. We'll get 16x to the fourth over 4 for 4x to the fourth, 24x cubed over 3 for 8x cubed, 4x squared over 2 for 2x squared, and then minus 6x to the first over 1, of course, still minus 6x. We're evaluating that from 0 to 2. We know the lower limit is irrelevant because when you evaluate all of those functions of x at 0, you get a 0. The only answer you're going to get is when you plug in a 2. I said 4 times 2 to the fourth, that's 4 times 16, 64, plus 8 times 8, 2 to the third is 8 for 64. Those two just cancel each other out. Then I have minus 2 times 4 is 8. Minus 6 times 2 is 12. I get my minus 8 times minus 12 for a total of minus 20. Now, when we go to the page and enter that in, it should be what they're looking for, the negative 20. Now, for the antiderivative, it looks like they're wanting us to enter that in as well. So that was my function here that I had before I evaluated it, let me make sure this will stay up on the screen so I can see the function and type it in at the same time. Let's see, maybe. Yes. Okay, now I'll bring this down and say my antiderivative f of x, that's this answer right here, are 4x raised to the fourth. And then we have plus 8x raised to the third minus 2x raised to the second minus 6x. And that should be the antiderivative. I checked that. Oh, doesn't like it. Let's see what happened here. My evaluation of negative 20. Okay, well, we'll see here. So whenever I evaluated this, for some reason here, notice the easy mistake. I subtracted that second term. It's supposed to be added, so silly me. Those 64s don't cancel. It'd be 64 plus 64 for 128, then 128 minus 20 should be 108 there. But the nice thing here, again, just like I did in a previous section, I'll say I made that mistake intentionally just to show you how easy it is to correct your mistakes and then put in the correct answer. I'll correct this on my page later for the 108. Check answer, and I know that that's right. Yes. And it didn't, it just has to remind you, it took you 2 attempts to solve this, but don't worry, gives you full credit. Next question for number 5. These get really quick and easy. It's asking us to use the fundamental theorem of calculus part 1 to evaluate the area under the graph f of x 4x squared from 0 to 5. All that is it's the integral from 0 to 5 of 4x squared with respect to x. So we say, well, the power rule tells us that the integral of that is going to be 4/3 x cubed. You evaluate that from 0 to 5. We know 5 cubed is 125. We'll have 4/3 times 125 gives me 500 over 3. Why did I not worry about the lower limit? Well, notice it was 0. So you'd just be subtracting 0, which does not change your answer. We go to here and say, answer is 500 over 3. Check that answer. And correct. The next one's similar here. For number 6, it's asking me to use the fundamental theorem of calculus part 2 to find the area between the region and between the x-axis and the graph y equals 7x to the negative 2 from 1 to 2. So we just integrate from 1 to 2 of 7x to the negative 2. Power rule tells me that this is going to become 7x to the negative 1. We divide by that new exponent, and we evaluate this answer from 1 to 2. Now, I wanted to go ahead and simplify this, that x to the negative 1 is an x to the positive 1 in the denominator, and 7 divided by negative 1 is just a negative 7. This looks much better. Negative 7 over x evaluated from 1 to 2 is going to be negative 7 over 2 minus negative 7 over 1. I know that subtracting a negative is adding a positive. This is the same thing as 7 minus 7 over 2. Well, that's 14 over 2 minus 7 over 2. Should be a positive 7 over 2 for my answer. I'll go 7 over 2. Check that answer. Correct. So now, for the next question here, we have the integral from 2 to 11 of x. This one's very quick. Power rule says that this is going to be x squared over 2. We're evaluating that from 2 to 11. That's going to be 11 squared over 2 minus 2 squared over 2. 121 minus 4 over 2 should give us 117 over 2. So there's a few really quick problems in this assignment. Number 8, it's the same type of problem. We're given a quadratic inside of an integral evaluated from 0 to 2. So we're trying to find the area between 0 and 2 between this function and the x-axis. When I integrate both terms, the first term becomes 4x squared over 2, or 2x squared. The second one, you'd have 15x to the third over 3, which gives me 5x to the third. We have 2x squared minus 5x cubed evaluated from 0 to 2. When I plug a 2 into this function, I'll get 8 minus 40. Well, 8 minus 40, that's going to give me a negative 32. Don't have to worry about the lower limit because you plug a 0 into that, you get a 0. My answer should just be the negative 32. When I check that answer, of course, it does say correct. For number 9, we have a trinomial in there, degree 5, that we're evaluating between 0 and 3. So whenever I did the evaluation on this, I had to first, of course, integrate, and you get your 18x to the 6th over 6, gives me 3x to the 6th. This term becomes 5x to the 3rd. The next term, 6x to the 2nd over 2, becomes minus 3x squared. We're evaluating this from 0 to 3. Yet again, you can just ignore the lower limit of integration because when you plug a 0 into that function, you're going to get a 0. The only answer you get is when you plug in a 3. I have 3 to the 6th power times 3. That gave me the 2187. Plus 3 to the 3rd power, 27 times 5. That gave me the plus 135. And then minus 3 times 3 squared. That's 3 times 9 minus 27. Put those into your calculator. You'll get a 2295 for the final answer for this integral. That would be the area between the curve and the x-axis from 0 to 3. Absolutely. Now for the next one here, number 10. Again, we're evaluating a polynomial on an integral this time. The interval goes from -2 to 0. I integrate each term inside there using the power rule. I'll have 2x to the 4th for the integral for the first term. The second term is going to become minus 11 over 3 t to the 3rd. I'm evaluating this from -2 up to 0. This time it's the upper limit that's irrelevant because when you plug a 0 into that function, you get a 0. Now you have to remember, always subtract the lower limit. Well, now I'm subtracting the lower limit, which is for the first term, when you plug the -2 into that, you're going to get -2 to the 4th is 16 times 2 is 32. And then you'll say minus, and I know it's going to be minus a negative, so it's going to be plus a positive. 2 to the 3rd power is 8. 8 times 11. You're going to get plus 88 over 3 for that. So then I said, well, 32 is 96 over 3. 96 over 3 plus 88 over 3. That's going to give me 184 over 3, but I'm subtracting both of those, so it's a negative 184 over 3. I check that answer. Correct. When I move on, for number 11 here, for the first time in this section, we don't have, or at least for the first time in a while, all of these have been polynomials. At least this one's a radical expression. So you have to think, well, that square root on the y, that means y is raised to the 1/2 power. So when I integrate that y, it's going to go y to the 3 over 2 power, and then require me to divide by that new power. So I'm thinking, well, that's the same thing as 5 times 2/3. So in other words, 10/3 y to the 3 over 2. Since the original was written in root form, I put my answer in root form, and I said, this is the same thing as 10/3 the square root of y cubed. I could have put the cubed on the inside or the outside. Anytime we're evaluating, it's easier to put that cube on the outside. The reason is because I would rather take the square root of 25 and then cube it, as opposed to having to raise 25 to the 3rd power and then find the square root of that number. Much easier this way. When I evaluate, square root of 25 is 5, 5 cubed is 125. I'll have 125 times 10/3. My lower limit is just going to be 0 because when you plug a 0 into that, the 10/3 times 0 is 0. I'll get 10/3 times 125, or 1,250 over 3. When we check that answer, it is correct. Up next, I'll have to go to my next page of where I worked out these problems. For number 12, similar to the one before, but now they wrote it as a fractional exponent, but remember, roots and fractional exponents, same thing. This could have been written as 125 on the 4th root of t. This time they put it as the 1/4 power, but the rule's the same, power rule. You'll say increase that exponent by 1 and then divide by that new exponent. So I'm thinking that's the same thing as 125 times 4/5. I know 125 divided by 5 is 25, times 4 gives me 100. So my simplified answer is 100 t to the 5/4. Then I have my evaluation from 1/16 to 1. You evaluate at the upper limit. You say, well, that's just going to be 100 times 1. Get your 100. Then subtract the lower limit of integration in the evaluation. And the way I thought about that is the 4th root of 1/16 is going to be 1/2. And then 1/2 to the 5th power is going to be 1/32. So that's going to be minus 100 times 1/32. And so then when I was simplifying this, I knew that this was going to be 3,200 over 32 minus 100 over 32 gave me 3,100 over 32. That reduced down in fractional form to 775 over 8. Of course, calculator can make that quick and easy. For number 13 here, I like this one. I like it because they specifically put it in a non-standard format, and this would confuse some students and make them think that it's a typo. It's not a typo. We're supposed to understand that the integral from 1 to 7 of 6 times dt over t squared. That dt is always just multiplied inside of our integrals anyway. So since it's multiplied, I need to understand that I could have written that as 6 over t squared times dt. And or even better yet, in order to use the power rule, that's the same thing as 6 times t to the negative 2 times dt. So the integral of 6t to the negative 2 with respect to t, power rule. I'll add 1 to the exponent, divide by that new exponent, and then evaluate from 1 to 7. I'd prefer to simplify this first. This is the same thing as a negative 6 over t, evaluated from 1 to 7. The upper limit's going to yield negative 6 over 7. The lower limit, you'll subtract it, and it's going to be minus 6 over 1. We know if you're subtracting a negative, you're really adding a positive. We're going to have 6 minus 6 over 7. That's going to give me 42 over 7 minus 6 over 7 for 36 over 7. Final answer. Now for the next question here, 14. We have the integral from 5 to 7 of 9 over x cubed. Similar to the last one, except it was already written in standard form. But it is best if you'll go ahead and understand that that 9 over x cubed is better written for the power form as 9x to the negative 3. So now I can look at it once it's in this power form. I can say, well, use my power rule. Add 1 to the exponent. Becomes 9x to the negative 2. Divide by that new exponent. Negative 2 goes to the denominator. Evaluate from 5 to 7. Before the evaluation, I would rather simplify and say this is the same thing as negative 9 over 2, and that x squared belongs in the denominator. Evaluated now from 5 to 7. You plug the 7 in. You'll get 2 times 49 in the denominator, negative 9 over 98. Minus the lower limit, but it's going to be minus a negative 9, so I just went ahead and put plus 9. And then my denominator is going to be 2 times 25, or 50. Negative 9 over 98 plus 9 over 50 gave me a positive 108 over 1225. And please notice in these problems, they are wanting fractional answers as opposed to decimals. My last problem I'll do here in this video, and I'll do the rest in another video, is number 15. It's asking us to integrate from 2 to 5 of x squared minus x to the negative 2. Okay, so x squared, easy power rule, just x cubed over 3. The next term, slightly tricky. We just say, well, again, it's the power rule. Negative 2 goes to negative 1. You divide by that new exponent. But now, when I'm simplifying this, I'll say, well, that's going to be minus a negative, which is plus a positive. This is really just plus 1 over x for that second term. Now we're evaluating from 2 to 5. When you plug in the 5, you get 125 over 3 plus 1 over 5. That's where this came from. Then you have to remember we're subtracting the lower limit in it. When you plug the 2 in, you'll get 8 over 3 plus 1/2. Upper limit minus the lower limit. When I did this, I just said, well, it's going to be 125 over 3 minus 8 over 3. That's 117 over 3. And then we have plus 1/5 minus 1/2. Gather all that in, get a common denominator, reduce it down, gives us 387 over 10. Let's check that. And yes. Okay, now problems 16 through 26 will be in the second video for this section. Let me know if you have any questions over any of these first 15.